is our 11th meeting, which is so exciting. Thank you all so much for joining us every month, every Monday for the past year. And we have a big anniversary celebration next month, so hope you join us for that too. Some quick announcements. If you were here last month, we're still continuing to work on a blog. If you have blog content, anything that you think might be helpful to the women in this community or to our allies, please feel free to send Alexa a message. And I'd also like to update everyone on our National Biomechanics Day sponsored fellowship for ASB 2021, which is our American Society of Biomechanics meeting. So big congratulations to Kayla and Sarah, who are going to be able to attend this meeting for free, thanks to the National Biomechanics Day. So we have a lot of great collaborations with them, and we're really excited that they were here. All right, and then I'm going to pass it to Brecca to talk about our membership survey that we just announced.
Yeah, thanks, Anna. So for the past couple months, we've been working on revamping our member survey. So over the last year, there's been a pretty significant amount of growth. And so we kind of want to take a resurvey of our membership with the main objective is, of course, to gather basic demographics, education, research, interest, etc. But also to gather information on how we as the IWB team can best serve you as members. So across the whole range of mediums that we interact with each other on. It's an anonymous survey designed, it only takes about 15 minutes or so, depending on how much thought is put into some of the short answer stuff. But it'll be really helpful just to kind of get our strategic plan moving forward to make sure that we are best serving you to the best of our abilities.
Thank you so much, Brecca. And you should have received an email, hopefully, with the survey link. So please fill that out by June 28th, so about 3 weeks from now. And we're excited to get your feedback. All right, I'm going to pass it to Kat to talk about our repository survey.
Yes, so we have a second survey link you'll have seen, hopefully, in that email that went out for you. What this is about is one of our projects is sort of over the next few months and moving forward is to put together a repository of resources for IWB members to access. And what we're looking to do here is to find out from you, firstly, what are the topics that people are most interested in? So how can we best help people provide information and resources that's going to be useful for people in their careers? And secondly, we want to hear from anybody who is willing to contribute to the repository or think they might have something to add. So whether that's a link or a set of resources that you've already collated or you already know about that have been helpful to you and you want to be able to share with other people, whether that's some original content that you've produced yourself and you're happy to share, or whether, for example, you've had experience applying for particular types of grants, whether successfully or unsuccessfully, and you're willing to potentially talk about those experiences or share resources, whatever you're happy to do with other members who might be looking to head on the same track. So please fill in that survey as well, because both parts of it will be really useful to us, again, to kind of move forward and create this as our next step. I will pop the links to both the surveys into the Zoom chat, shall I, Anna?
Yeah, that would be great.
Brilliant. And then everybody will have access. But yes, please do both surveys because the information will be really useful to us and therefore useful to you.
Yes, thank you so much. And thank you so much to the team, the member support team that's been working on this for the past few months. All right, and then one other quick announcement is that, as I mentioned, it's going to be our first anniversary in July. I'm very excited. So we are going to, hopefully please fill out that survey because we're going to kind of recap the year, get your feedback, see how we can improve for next year and just kind of get to know each other, meet each other and celebrate. So look out for more information on that. But it is our first Monday of July is actually July 5th. And I know a large population of our membership comes from the US, and that's a holiday. So if you could just flood the chat and let me know if you prefer July 5th or July 7th. So just type either Monday, July 5th or Wednesday, July 7th. That would be a huge help to us. And we'll pick a date that works for most of our members. So we start flooding the chat with those options. And then with that, I will pass it to Amanda for a wonderful session we have planned for you.
Hi, thanks, Anna. I am so excited about tonight's meeting. I am excited to hear from these lovely women discuss their careers in biomechanics. Biomechanics can be such a diverse field, and I think sometimes we just get stagnant in thinking of in terms of academia or even stagnant in what industry means, that I'm excited about some curveballs that some of these ladies are going to present to us tonight. So we have Dr. Morgan Turner, who's a postdoctorate associate in community innovation from the University of Minnesota. Maria Pasquale, who's director of application for Novo Electronics. Dr. Karen Kruger, a motion analyst engineer with Shriners Hospital. Dr. Brooke Odle, assistant professor in the engineering department with Hope College, and Dr. Rebecca Fellin, research biomechanics for the U.S. military. So exciting lineup. I hope you have get your questions ready. Please feel free to put your questions into chat as we go along. We will also do an open Q&A at the end of the talk. And we will also do a breakout room at the end of the talk so you can get to talk to them more about their career path and how did they end up where they are. So we will start off the meeting with Dr. Morgan Turner. So the floor is yours.
Thank you so much, Ramanda, for assembling us. This is super exciting. I was just having some technical difficulties, so this should hopefully all good. See my screen? Cool. So thanks again, Ramanda, for organizing us. I am a postdoc. I believe I am the only representative from this group. And I am at the University of Minnesota in the Department of Computer Science and Engineering. And I'm really excited to share with you guys my kind of winding path on how I ended up here and maybe where this is going to take me next. Okay, so this was a really fun exercise to try to condense down my timeline into 2 slides. So here we go. Prior to 2010, I was a young child and I really was excited about bones and drawing them. And I started volunteering at the Burke Museum of Natural History and Culture in Seattle at the University of Washington. And I was just really fascinated by the shapes of these extinct animals and their skeleton and why they looked so different from modern animals. And that just really launched a lot of interest of mine into getting more into paleontology. So I decided to go to undergrad at the University of Washington, where I was a biological anthropology major and a paleobio minor. I switched around a lot, majors, even studied prisons for a little bit, but ultimately really ended up loving and being drawn to understanding the shape of bones, where they come from, how they've evolved, how do they function, all these things. And so I joined a lab that focuses on paleontology around the Triassic, and I started doing a project. It was my first research project, just studying some limb bones and a bit of ontogeny, which was really fun. And so all of that got me really excited about the shapes of bones, but ultimately I really wanted to understand how did they move, and also I really love to draw them. And so I think someone might be unmuted. Sorry, there's some laughing, I think, in my ear. It's weird. Anyway, so after that, I did not immediately go to grad school. I decided to take a 2-year break. Wasn't planning 2 years at the time. And I really wanted to learn to get better at illustration, scientific illustration of 3D forms and translating them into 2D on a 2D plane. And so for 2 years, I worked for a couple of museums. I worked as an artist in residence at a national park. I also was a peer TA in comparative anatomy, mammal evolution, just really getting excited about teaching anatomy, understanding 3D structures, and conveying them, communicating them in some way. And so after all that, I really realized I didn't like illustrating just for other folks. I really missed doing research, and I was doing a little bit during that time, but I decided I wanted to go to grad school and I wanted to understand how bones moved and why they did. And so I went to Brown University and I worked with Steve Gatesy, the guy in the white shirt right here. And when I started at Brown, there was an ongoing collaboration studying dinosaur footprint formation. And so how do these dinosaurs that have these tridactyl feet, 3 main toes in the front, how do they sink into the mud, make footprints, and how do we extract locomotor information from that? And so when I started at Brown, learning a lot of this data, working with some biplanar X-ray videography data from guinea fowl moving through different muds. And so I'm animating the skeleton of these feet. So here's some bird feet here, sinking in different muds, trying to understand how they're moving. But at the same time, my very first semester I began, I started our collaboration was contributing data to this data visualization course. So it was all about virtual reality visualizations and creating them to solve a problem that some data scientist has or domain scientist. And so we have these particle simulations of dinosaur feet and bird feet moving through mud, but how do you take this dense volumetric data and actually distill down patterns from that to actually visualize important, meaningful things that we can take back to the fossil record. And so that whole combination of me trying to understand the skeletal motion, the patterns of really complicated, messy animal locomotion, and then also, you know, this exploring this whole realm of data visualization and viewing things in 3D, really was just like this formative kind of mind-opening experience on how excited I am for really approaching data visualization with animal data. And so towards the end of my PhD, I got some live alligators, acquired them, trained them to walk on treadmill, and did surgery, and ultimately collected an amazing amount of data on their huge amounts of movements, both forward walking and all these crazy maneuvers that they do. And I'm slowly animating their entire foot and all the bones inside of it. It's a really messy, complicated structure. And one of my favorite things is just how difficult it is to understand the patterns of movement of these many bones. And then how do we take that and start to relate that back to the fossil record, where there are all of these feet that look very similar to alligators. There's this huge lineage of animals that have evolved before them. And so how do we take these birds in this data, and how do we take these alligators and their data and start to understand more about how extinct animals once moved, how their feet are interacting with the ground, and what we can say about how they're using feet in terms of posture and moving through the environment. And so at the end of 2020, in December last year, I defended my PhD and quickly moved over the new year to my new job. And I will point out, I put these bars down below on kind of these 3 main fields that I'm gaining skills in throughout this timeline: paleontology, and then developing these visualization skills, and then ultimately moving into biomechanics. And so that takes me to my last slide here, where I am right now at the University of Minnesota. I applied for a computing innovation fellowship last year, knowing that I was going to graduate soon. Didn't expect to get it, and did. And it was really exciting. Quite a bit of imposter syndrome because I only learned how to program in grad school, and I don't think I'm very good at it. But I'm incredibly excited to be in a interactive visualization lab. So it's a bunch of VR specialists and researchers, and they create these amazing interactive visualizations for complicated data, and they're really geeked about this kind of stuff. And so I am here to work on developing an application to better understand 3D animation kinematic data of these complicated bones. So here you can see some of the alligator feet here. Here's some bones of the alligator foot. And starting to actually address learning patterns, interactively exploring them, analyzing them, and communicating them by connecting them with 2D graphs so that we can learn these patterns, zoom in, go back and forth, and actually really start to understand the mechanisms at work. And that's all so that we can actually start to bring in fossil bones back into the picture. How do we begin to apply this motion to, not even apply, but use this live animal data to start to understand and explore morphology of extinct animals? And so a lot of this stuff is at work, but one of my favorite aspects of where things are headed right now is communication. And that's communication for the purpose of a researcher and like specific people to my domain. And so trying to create an interactive web application to kind of explore some of these uncertainty aspects of the work. But more importantly, how do we communicate this information to the general public and getting the general public engaged in basic science? I think that's a really important aspect right now these days. And so my lab has a collaboration with the planetarium at the local science museum here. And one of the things that I'm really geeked about is that this lab is very excited about storytelling, data storytelling. And how do we bring in climate science? How do we bring in biomechanical data, medical data? How do we incorporate all of these things into a story that we can actually start to communicate what we've learned about the past, presently, and then how do we start to apply that in the future? And so for me, maybe things are starting to head. I might try to collaborate with some roboticists because there's some cool like function things that I've learned about how feet work, that maybe there's like something interesting there. But also importantly, just like understanding the process of science and how do we learn these things is an important takeaway for a lot of this biomechanical stuff. So what's next? I've decided that at the moment, I'm still very early in my postdoc. It's scheduled to end at the end of 2023. It's only 2 years. I don't know what's next, but I do know that I'm embracing my interdisciplinary identity. I've like officially decided that about this week. And so I'm excited about what's next. I don't know what it is, but I'm excited to keep kind of pulling more things in, working with more people, and just seeing where all of this can go. That's me in a really quick nutshell. Thank you for listening.
Thank you, Brooke, for that. Again, the questions will be after everybody, but thank you because I already saw some curveballs in there because when I started, I never thought about biomechanics and like telemetology and working with animals. So that was very cool. Becky, you are next.
Okay, thank you for that introduction. I am very pleased to be here today. Can everybody hear me okay? Okay. I'm on my phone because I have some internet issues, so that's why I wanted to make sure that it was still coming through okay. So my talk's gonna be a little bit different. I'm gonna focus on what decisions led me to decide that I wanted a career in military biomechanics, doing whole body human movement, and some focus on the lower extremity as opposed to taking that and being a professor or working in industry or working in some other novel area. So because I work for the government, I have to tell you I'm presenting everything that's my own. I'm not officially representing the Army or the DoD in terms of any of the viewpoints I'm talking about. So I decided to make a slide that has everywhere that I have worked or participated in. And my journey to where I am today started back when I was in elementary school, and that I was really interested in math and science and medicine. I was trying to figure out how can I do something that combines all of those. When I was in high school, I became an EMT. I rode on an ambulance. I taught swim lessons. I enjoyed working with others, as well as doing things that had a lot of focus on science and medicine and how to help people in their time of need. At that point, those people were anyone who was calling 911. I was very interested in doing something more researchy or math and sciencey, and I was looking into schools to go for engineering, and RPI, or Rensselaer Polytechnic Institute, had this 2-week completely free program for underrepresented minorities in STEM to go spend 2 weeks there, and they would have you attend different classes. Sorry, my phone just ended the call for some reason. Can you guys still hear me now?
We can hear you.
That's good because I switched over from what I was on. So I was in high school and RPI had this 2-week completely free program to take some classes in engineering and try to convince you to go there. And it worked for me as well as a handful of other people because I really enjoyed the campus and I enjoyed seeing something that is, okay, this is really math and science focused, and biomedical engineering was something I could add in the aspect of wanting to help people. Although certainly any type of engineering or biomechanics, you have a component of that with it.
So I then did my undergrad at Rensselaer for 4 years, and they have a very big co-op program. So spring of my junior year and summer of my junior year, I went to the Lerner Research Institute at the Cleveland Clinic and dove into working on a research study that was just getting IRB approval. So I was able to see what was involved in that process through collecting data, processing data, and then working on writing up manuscripts. And that really led me to realize, I think I could handle doing this for more than a couple-week internship. I think I really want to go to grad school because I don't want to be told what research I'm going to do. I wanted to have some input into deciding, I think this is an interesting question and I want to go there. So I started talking with the people I was working with, Scott McLean and Ton Vandenbogert, and asking them for advice about where could I apply to grad school? What might I want to be doing? I'm interested in this. I have no idea what this whole process is. And thankfully, ISB, ASB was being held that year in Cleveland. So I was able to attend that conference and see lots of research and really think this is fascinating. I love this. I don't understand all of it, but I want to keep learning more. I think I'm in the right spot. And then I applied to graduate school and I was admitted to the University of Delaware, where I started working with Dr. Irene Davis. And I'm someone who prefers a bit more one-on-one attention. I would feel lost if I was in a lab of 25 people. I know that's really a personal decision, whether you want a really big lab or you want something smaller, who's giving you your mentoring. So for me, that was the right size fit, although for some people, definitely a larger lab is a better fit for them. And while I was there, I was talking with one of my lab mates and asking him about the research he was doing. And then he mentioned that he worked for the Army and they were paying for his PhD. At that point, I didn't know the Army had scientists who actually were biomechanists who were designed to study whole body human movement, see how it relates to performance and injury, and how the equipment that soldiers are wearing may influence how well they perform. So I was quite intrigued by that. And when I started applying for postdoc positions, I applied for some in the military as well as some in a more traditional civilian route. And I selected one in the military because I thought it made the most sense. If I'm considering that as a career, I should probably take that postdoc and then decide, is this really the research path for me? Do I think it makes sense? I know that I've always heard the government has some bureaucracy. Can I handle it? Do I hate it? Do I love it? So I came to USARIUM, which is the U.S. Army Research Institute of Environmental Medicine. And I was mentored by Joe Say, and he was able to help teach me how the government works, how the bureaucracy works, what does doing an IRB look like in the Army compared to if you're in a hospital. And thankfully, I'd been at the Cleveland Clinic where they have slightly more rigorous requirements than some institutions do. So I was used to there being lots and lots of sessions in a standard form.
Thank you.
I think someone has a hot mic. So through that time period, I then was able to be mentored on becoming a principal investigator in the Army, understanding how all that worked, asking questions, understanding what is the military interested in, because in order to get funding, you have to ask a question that's relevant, which is common to wherever you're working. Yet in the military, it's a completely different process. It's not a super difficult process. You just need to learn it and understand what it is. So then I applied for a equivalent of an assistant professor position back in 2013, and then I was accepted for that in 2014. So I'm currently at the level of an assistant professor, and I'm loving what I'm doing, that I'm able to ask questions that are relevant. And what I prefer about the military compared to other places is you're required to have outcome metrics that are making a difference within the next couple of years. So while you have your eye on the what are we going to do in 20, 30, 40 years, you have to have something that's going to be relevant in the next couple of years in order to have funding, which helps you think about what questions can I actually answer from a biomechanical perspective. A lot of times that means I'm collaborating with other researchers to be a biomechanics piece of a larger study, because you can't go out and collect data on thousands of soldiers by yourself or even hundreds of soldiers. It can be difficult to get very large numbers of participants if you want to look at injury or performance metrics. So when you collaborate with other people that soldiers are already doing a study, you're then able to get that information and ask those questions that we think are very important. So in conclusion, Okay. So my advice for everyone would be always ask for guidance. People are generally happy to help. I found when I was at the Cleveland Clinic, the Learner Research Institute, I was able to talk to other researchers and they were all very willing to help me. I really didn't know what I was doing as an undergrad, and looking back on it, I'm recognizing and thinking now I need to be just as friendly and encouraging to undergrads who are interested in biomechanics and not expect them to know everything, and encourage them that it's okay to not know answers, and that's completely normal. And it's good that you don't know all the answers because then it wouldn't be research. Finding a lab that's the right fit for you. There's so many different styles of learning and communication. Make sure that you're talking to any potential advisors, and especially graduate students or other postdocs, about what you're interested in, how that fits. It's also important whatever working environment you go into. And finally, always make sure you're finding mentors throughout your career, both inside and outside of your career field. I have loved being in the Army somewhere that there's only a couple biomechanists, because I have mentoring from other biomechanists, but then I have to receive mentoring in my building from people who are in different fields, but they can help me in ways that someone who's a biomechanist that's not in the Army simply can't, because they don't have that background. So thank you for letting me present today, and I'm looking forward to talking more with you later.
Thanks, Rebecca. That was a great view of how biomechanics can be used in the military. Maria is next.
Great, thank you so much. So let me just share my screen now. And I'm hoping everyone that my voice keeps up for today. So I apologize if I'm a little hoarse. So yeah, thank you so much for inviting me here today. I'm happy to talk with you guys. I think listening to Becky, I have a very similar take on how I got here in my early years anyhow. But where we ended up is very different, and probably where I ended up is maybe the largest difference from the norm in this group, to be honest. So first, just like a brief bio about myself. I think this is important. Oh, sorry, I'm trying to move this stupid video window out of there and I went backwards far. Okay, so who am I? And I think this is really important to think about, like in my life, especially at this time. I'm a mom, I'm a wife, I am a biomechanist. And I added this as I'm a former road warrior, because we don't travel anymore right now, right? But for 18 years prior to the last year, I traveled once or twice a month at least to conferences, customer sites, etc. Diversity, equity, inclusion supporter. I love animals. I love gardening. I CrossFit, but I wouldn't call myself a CrossFitter. I'm not that. I'm just kind of a CrossFitter. I love to binge Netflix. So I like to start with something like this, because this kind of just gives you an idea. And I think it's really important that people understand we're more than just, you know, whatever they see on a Zoom meeting or at a conference. You know, we have big lives with big things going on. I have my, also a little different than everybody else, I have my bachelor's and master's in bioengineering from the University of Pittsburgh. I do not have my PhD. I'll talk a little bit more about why that is and why I made that decision and how I got there here kind of on this next slide. So I'll back up a little bit even more, which is kind of fun. I've always enjoyed technology. I think, and there may be some kids who never even, or some people who've never even experienced this, but when my family in the mid 80s got the VCR, no one had any idea how to program it. A VCR is this thing with tape and you put a thing in and you watch a movie. Okay. I'm just kidding. But seriously, I read the manual. I was really interested in that. My parents were literature kind of people. My dad worked for a newspaper. Math and science were like the exact opposite of everything that they thought was, not that they didn't think it was important, but what they were intrigued in and what they did. And I found that really exciting. Like Becky, I really liked medicine. I really liked the idea of helping people, but I really liked math and science. And that's how I happened upon bioengineering. I was actually bioengineering was a very new field. I didn't even know it existed, but I had a really great guidance counselor in high school that I also like geographically said I wanted to be within this area, and she started to help me. And she said, well, there's this new thing. It's called bioengineering. I don't know anything about it though. And I was actually the second undergrad class ever to go through Pitt. There was, I think, 18 of us that graduated in that class, I think, or that school now, that just program of bioengineering at Pitt, I think has like 250 students now in their undergrad, each of their undergrad classes. So it was very, very new at the time. I didn't really know what it was, didn't really know what I was getting myself into, but just thought, hey, I like this and I like that, and I'm going to try to meld these. I think very quickly I realized, I did very well in high school. I loved the math and science, but when you went into a bioengineering field, you took all the hard engineering classes and you took all the hard bio classes, and that didn't meld well for me. I also like to have fun, so that didn't always meld well for me. So I had a really wonderful advisor, and again, finding those right people is so important. And he brought me under my wing, and I said, well, this is what I like. I like the medicine. I want to go help that guy whose knee hurts because he just tore his ACL or whatever. And he said, okay, well, they have this new sports medicine institute, and you should start to talk to people there. And I said, okay, great. So this was also around the time that 3D motion capture was becoming popular. Again, I'm dating myself. I don't think we necessarily went in order of career, because I think I happen to be a bit older than a number of other people. But this was when 3D motion capture was just starting. I mean, just moving from video to optical systems. And a sports medicine group had a 3D motion capture system, but they didn't have an engineer. They were all clinicians and they didn't know how to use it. And I started working in their lab. And that's what really allowed me to have exposure to technology and exposure to bringing medicine and science together and working with clinicians, PTs, athletic trainers, orthopedic surgeons, and saying, hey, I know how to program in MATLAB. None of them knew how to program in MATLAB. And they, so bringing these skills in, again, that research lab has gone on and produced, top PhDs and brought in lots of engineers after that fact. But, it was an interesting meld of these two things. So I enjoyed that research in grad school. I enjoyed the project design. I enjoyed piloting. I enjoyed collecting and analyzing the data. I didn't necessarily enjoy teaching, and I didn't necessarily enjoy public speaking, which is ironic because I still ended up doing that even later. So that's kind of how I ended up at that point in my career. And I said, well, look, I don't necessarily feel I want to get my PhD right now. I really enjoyed traveling, love meeting new people. That was really important to my personality, having exposure to new people. And, I really enjoyed that technology aspect of working with the technology. And again, because I was at this lab at the time where I was the only engineer, whenever something broke, I was the one that contacted the company and learned how to fix it. And I worked with a prominent motion capture company and found mistakes in their programming of what they were putting out there for the entire biomechanics community. And through that work, I was able to get a job as an application engineer. And through one of the motion capture companies here within our field still today. And that motion capture company did integrative systems of all different types of technology, the motion, the EMG, force plates, even virtual reality systems, all of it. And I got exposure to all that technology and really lots of different applications using that technology. That's what's really been very interesting is the amount of exposure that I've been able to get. So here we are 20 years later almost. And really countless relationships, research projects. I enjoy mentoring, students. Many times I get calls from students who have never had any exposure to technology and they need help learning that, and we get the opportunity to do that for them. We speak with our customers every day. We understand their research projects. We understand how our technology is used. We know how it's used with other people. We help people build relationships because we know how they're using it, and we know that their research is overlapping with so-and-so's research, and maybe they should talk to each other because maybe they'll ask a different question that even gets and advances our field in a different way. And that's really what it's all about, is building these relationships, advancing our field, using our technology to really take things to the next level in biomechanics. And that's probably a lot different than, when you have a problem with some equipment you're using in biomechanics and you email, support@suchandsuch.com, that you think that person responding is. And this is where I want to talk here a little bit more about what is the right fit, because that's very hard to choose. I mean, it's the right fit is who you work with. I'm extremely lucky. There's really just two of us here in the US side of Novell that work together. We've worked together for over 15 years. This is Susan D. Kruger. I think she joined us for this meeting. And, I'm very lucky that we have a wonderful relationship, and I have a lot of support. But that's also really important, what support you have. It's about mentoring, and as Becky said, within your company, but then going outside of or your university or whatever position you're in, but also going outside of that. And when you're choosing a career, when you're choosing a place, talking and having experience with other people who have either been in that position before you were, or in a similar position in a similar place, and finding out, like at a university level, do they have the right mentoring? Do they have the right support for you for not just your career, but what your personal life is going to be? Are you going to receive, support if you want to take family leave when you want to take family leave, not when it works well because there was a grant, application due or whatever? What support you have is very important in how you can achieve a good fit and a good career, and where you work. And this is kind of ironic. I have worked remotely from home for these past 15 years. So I used to live in Chicago and I worked remotely from there. Now I live in Pennsylvania, which is where my family is. I had the opportunity to move here when we had our children and be close to our grandparents. That's my backyard. I look out my window. I was working from home way before it was vogue, and now we're all doing it. And we're, but where you work is really important, and who those people are that you're working with and how they support you and your ability. We all have to be comfortable now working from home or working from alternative locations. We've all learned that in the last year, I think, for sure. But are you, and I'm going to get into this in a little bit, but are you in a small company or a large company, or a small university or a large university? Where that is, really matters as well. I'm going to get into that here now, but how you work and how you operate. Are you someone, for example, now that we are working remotely, are you someone who lives alone and therefore doesn't have exposure to a lot of other people, but is someone that has a very outgoing personality, enjoys being around people, and not having that could be detrimental to your mental health, for example? So finding that right fit of, do I have the opportunity to go in if I wanted to go in somewhere, or have exposure to additional people if I wanted to? How you work and how that's achieved really needs to be that right fit for yourself. And then small versus large as well. From a company perspective, this is very important. A small company has Perhaps, I'm going to generalize here, you might have more flexibility. I certainly, as someone in a small company, wear way more hats than somebody in a large, company, or somebody with a very structured job description. Some days I'm doing social media, and I'm doing our Twitter posts, and I'm creating, graphics to be placed on the internet. Some days I'm on with the development team and I'm testing hardware and software. Other days I'm training, I'm training a new group on how to use equipment. So it varies quite a bit. A large company, though, might have a much more structured plan of this is where you start, this is how you advance, this is how you achieve whatever that goal is, if that's a certain title or a certain level you want to be at, or monetary, you might have that path much more clear in a large company, and you might feel much more comfortable with something such as that. You might have more resources, there might be more benefits that you receive at a large company than a small company. These are all very important. And again, your success is going to benefit on how that fits you. And I think that matters too at the university level. A smaller university that isn't so research driven might have more flexibility in either research ideas or questions or, funding, but then you might not have the large funding capabilities that you might get at an R1 institution. So again, each of this really has to go with what works well with you and your personality. So that's really what I had to say. Half about how I got there, and half about how I think other people can consider things in their career, and excited to chat with you guys here in a few.
Thanks, Maria. Can I just say I'm glad you spoke on the importance of finding the right fit, because I know sometimes even with me, as I look for jobs or I can get caught up in like the description and the title and the salary, but you don't think about all the little things that will probably make you more happy in terms of the company size and the people around you and all of those little nuances. So I'm really glad you spoke to that. Karen, you are next with your career pathway.
All right. Get this presenting. All right, so thanks for letting me present. I know everyone else had kind of talked about how they got into biomechanics, so I can talk a little bit about that. I was an athlete in high school, like I'm sure a lot of people were. I was in competitive cross-country running and Nordic skiing, and as many runners, dealt with a lot of running injuries. And my interest in biomechanics was actually sparked by working with physical therapists who I thought were cool. And initially, when I was like a junior, senior in high school, I was kind of thinking, oh, physical therapy would be kind of a cool program to end up at. So that's what I was actually exploring colleges for. But at the same time, I was kind of not sure if I wanted to do direct patient care type of applications, because I also really liked the science and math end of things. So I know people like to say my mother doesn't always know everything right, but my mom had kind of said, like, maybe you should look at this biomedical engineering field. It's kind of a newer thing and you might enjoy it. You can always go into physical therapy school after that. So I did actually end up taking my mom's advice and went into a biomedical engineering program at Michigan Tech University up at the end of the road in northern Michigan. So I actually got a dual degree in biomedical and mechanical engineering. And I just wanted to show a few different pathways that I explored while I was there, because mechanical engineering, especially as with biomed, is so broad. So I did one internship with industrial control systems at Rockwell Automotion. I worked at General Motors on an internship looking at human vehicle interface and how seat design and seat comfort works. I also did a summer with John Deere working on the manufacturing floor of these big tractors and looking at some of the different ergonomics issues that arise with factory workers. But the one summer project that I really did that really lit a spark with me in biomechanics was working as an undergraduate research assistant in Dr. Tammy Donahue's lab, looking at knee meniscus mechanical properties. And we were looking at actually the impact of unloading the meniscus. We had some funding from NASA to look at like what happens if astronauts in space are unloading their joints for weeks or months at a time. So I distinctly remember talking to Megan Killian, one of the grad students at the time in the lab, and I was like, I think I've looked into a lot of different things, and this is what I really want to do. And she was like, sounds like you're going to grad school. So that was the route I took, and I really liked the more like end-stage arthritis, total joint replacement area. So that's where I chose to focus looking at graduate schools. And I know sometimes we like to think of some of these pathways as being premeditated as why we end up certain places. I admittedly looked at the University of Iowa because I had a serious boyfriend at the time who is now my husband who got a job offer in Iowa. So that's what led me to look at the University of Iowa. And it was like the stars kind of aligned, and they had the orthopedic biomechanics lab there led by Tom Brown, who is really well established in the field and had a PhD position open to do computational modeling and total hip replacements that I was lucky to get hired to do. So I started there on this project looking at third body wear in total hip replacements. So I worked with a collection of a bunch of retrieval total hips. And what we wanted to look at were why do some of these metal and polyethylene total hips wearing away at different rates. And I was able to develop a finite element model that showed the amount of damage that some of these femoral heads were getting could lead to 10 times the wear on that. So that whole project was finite element modeling, a lot of sitting on the computer. And I really wanted to get a little bit more of the human interaction back in biomechanics and look into where are we getting some of these input data for these finite element models. So I had a job offer to do a postdoc at Marquette University with Dr. Jerry Harris, whose research is focused in joint or motion analysis in both pediatric and adult populations. So I was able to learn clinical gait analysis, both looking at some adult total ankle replacement projects, but what really lit my research spark was working with the pediatric lab at Shriners Hospitals for children, where the lab looked at a variety of different movement disorders like cerebral palsy and some different foot disorders. So I was able to work with the team there and do a couple different research projects, and was able to kind of slide in right place, right time, and get hired for my current job, which is a motion analysis center engineer at Shriners Hospitals for Children in Chicago. I also do have a research assistant professor title at Marquette University, so I'm able to advise graduate students and undergraduate students and bring engineering projects to the GATE lab to help hopefully benefit both sides. So my current job is 50% clinical lab support and 50% research. So this is what our clinical gait lab looks like. We have kind of standard gait lab, 14 of the motion capture cameras, 4 force plates, and then EMGs that we use to do kind of the standard lower extremity kinematics. And this is just a long list of the tools that me and the other engineer are responsible for maintaining. In addition to some of the standard stuff, we've also got the EMED planner pressure system that Maria works with, a biodex system for strength testing, a neurocom that lets us assess balance and posture stability, and then smart wheels that allow us to look at wheelchair dynamics. So we see children with any sorts of pediatric motion disorder. We see a lot of cerebral palsy, myelopathy, club feet, tarsal coalition. So any kids that the orthopedic surgeon think would benefit from a gait analysis, we see. And this is the team we're currently working with. And this is the part of my job that I absolutely love the most. We have a team of physical therapists and kinesiologists that are testing the patients on a regular basis. and then myself and 2 other engineers that do the technical side of things. And then a group of orthopedic surgeons, PM&R physicians, and an orthotist that are referring patients to the lab. And every Tuesday we get together and the physical therapists compile a gait report and then present it to the physicians that are treating the patients. And we use that to put together a treatment plan for the kids. So the case review, we end up looking at a bunch of graphs, which I'm sure anyone who's worked in gait analysis has seen a bunch of times. So we have all of their kinematic and kinetic graphs. We also have a physical exam. And then depending on the case, the physician or physical therapist can make the decision to include things like segmental foot kinematics, open sim muscle length, neurocom, and then we're responsible for kind of, it's almost like putting the puzzle together in which pieces of information are most relevant to putting a treatment plan together for that kid. And it's really nice as an engineer to actually be involved in the medical decision-making process, especially when we bring in things like OpenSim, where they're like, what does this mean? And we've actually got them thinking about things like muscle length and joint contact, and being able to bring in some of these newer engineering tools that we've been seeing for years. So that's the clinical side of things. One of the other things I really like about this job is we can use questions that come up in those clinical case reviews to guide new research problems. So we see a lot of feet and a lot of really complicated foot disorders that can't really be visualized with common traditional motion capture. So we've been working with the team at Marquette University to do both single plane and biplane fluoroscopy to look at ankle motion in a more complex fashion. We also do a lot of work with ankle foot orthoses and a concept called tuning, where instead of just using a standard brace locked at 90 degrees, we can look at how to vary how much posting is underneath the heel. And this process has typically been led by physical therapists, and they tend to just do a lot of like, modify, okay, it looks right. And we're looking at using a more strategic engineering approach to get more quantitative data out of this. And then the last project we just started to venture into is machine learning. So engineers tend to like data, and we'll collect anything we can. So as part of these case reviews, we end up with kinetics, kinematics, EMG, muscle length, all these different pieces of information that the surgeons have sometimes just 10, 15 minutes to synthesize and come up with a treatment plan. So we want to look at some more structured machine learning approaches to look at what factors best predict a certain surgical success. So in a nutshell, that's what my current role has been like as a clinical motion analysis center engineer. I'm happy to take questions or discuss more in the breakout rooms.
Thank you, Karen. That was great to see how you work with children in a hospital. I never worked with kids before, so for me, it's always interesting to work with so next we have Brooke. Next.
Hi, just want to make sure you can see my screen okay.
Good.
Okay.
Yes.
Great, thanks. So just wanted to give you all just a little bit about my journey. So thank you all for having me speak and just share. And I do have my Twitter here. If you want to follow me on Twitter, feel free to do that. So just to give you a little bit about me, I am originally from New York City. I identify as a woman, and I identify also as a woman who is Black with Puerto Rican roots. So one of the things that was important to me growing up was that my family was very civic minded. We were very involved in our community. So one of the quotes that grounds me is Dr. King's, life's most persistent and urgent question is, what are you doing for others? So I tend to view everything that I do from a lens of service. And I also went to the University of Pittsburgh and have a bachelor's in bioengineering from there. So not only did that shape my journey in biomechanics, but also as an undergrad, I pretty much did research. And one of the projects that I worked on was understanding strategies that people with spinal cord injury used when they were transferring from their wheelchair. So going from their wheelchair to some other surface. And so pretty much just biomechanics is what solidified my path being at Pitt, but also spinal cord injury became a very important part of the research that I did, and using biomechanics to find ways to understand injuries and using technology to help people be safer and more independent. And then lastly, so at my current institution, we use the Strengths Finder, and it wasn't until I started thinking about my journey and thinking about my strengths, how everything kind of came together. So my first one is restorative, like I like to solve problems. Next one is learner, like I like learning new things. Connectedness, so that nothing is random, kind of like one of those like everything happens for a reason. I'm also a developer, so pretty much like being able to not only invest in myself, but also investing in others and looking at their growth. And then last, my top 5 strength is harmony. So again, having that community mindset and being very collaborative. So I also like memes, and so I think about how we see kind of like that, how it started versus how it's going. So again, starting off University of Pittsburgh. When I finished there, I wanted to be closer to home. So I went to New Jersey Institute of Technology to get a master's. And at the time, no one had anything related to spinal cord injury and biomechanics. So I went into a lab that was focused on children with orthopedic disabilities. And one of the things that that they were doing in the lab was using MATLAB and the Sim Robot toolbox to make adaptable video games for children with severe disabilities. So children who couldn't use like a Wiimote or any sort of commercial video gaming platform. And so part of my job was working with some of these games, like working with physical therapists and occupational therapists to develop these games for children to see how we could use it to augment their therapy. And then on the biomechanics end, looking at their movement. So in the picture, you see a child holding a cup, and there's a sensor on the cup. And the game, we had a webcam, and the webcam would recognize either color red, green, or blue. So he has a blue cup. And as he moves the cup, the webcam will pick up the movements of the cup. And there's a little hand on the screen that's kind of like his virtual hand. And that's how he can engage with the game. So I was looking at reaching, seeing if that was going to help them augment their therapy. And when I finished that, I had an opportunity to work at the Kessler Foundation. So our PhD program was joint with Rutgers for biomedical engineering. And some of the faculty worked at the Kessler Foundation, and they were doing work spinal cord injury, wheelchair propulsion. So that was my opportunity to get back to that. And with my PhD, I learned about OpenSim, and I looked at modeling the shoulder and the chest for wheelchair propulsion, particularly in people with higher levels of spinal cord injury. And something that I was kind of doing, it kind of started off as like just something on the side. I needed some extra funding, and I had an opportunity to participate in an NSF GK12 Fellows program where I was paired with a math teacher at a local high school and I was like the resident scientist or engineer in the classroom. And I would have to relate my research to what they were learning, and couldn't always relate wheelchair propulsion and computer modeling to algebra and geometry. So I started thinking about other applications within the STEM field. And when that ended, I had another opportunity to work with the W.E.B. Du Bois Scholars Institute, which was housed at Princeton. So again, primarily here working with middle and high school students from historically marginalized backgrounds from New York City and the New Jersey area, and developing classes for them in math, logic and reasoning, and then computer programming and coding. So after I finished my PhD, I knew I wanted to stay in spinal cord injury, and I wanted to do some more work with modeling, and that brought me to Case Western Reserve, where I did my postdoc in the biomedical engineering department. And particularly the lab that I worked in was at the VA hospital in Cleveland. So I was working with implanted stimulation systems, and one that I worked with primarily was one for standing balance. So I was able to learn about the control systems, getting a little bit more involved with experimental biomechanics. I did some modeling, some things with neural networks. And one of the projects that I ended up doing was kind of like the side project. We worked with a physical therapist, and she was noting how, one of our participants, how their family member was transferring them and saying, they can do that now because they're young enough, but at some point, they're going to hurt their back. And we got this idea, well, what happens if we turn on someone's stimulation system while they're being transferred? What does that do to the caregiver? And those preliminary experiments kind of made us realize, well, we need a model. So I started looking into musculoskeletal modeling and kind of getting into patient handling. So when I had an opportunity to think about, what was I going to do next, I realized I liked research. And throughout my postdoc, I continued my relationship with Du Bois and taking on some more administrative and like teaching types of things. And I realized that I needed to have both. So that kind of brings me to my How's It Going, where I got to Hope. And first I started as a faculty fellow, so I wasn't sure exactly where I wanted to be with respect to academia. I just knew that I wanted to teach, but I also wanted to do research. And I had this really unique opportunity to come to Hope as a fellow last year. Hope is an undergrad institution, so it's a small liberal arts college, and it's known for its Christian faith, and it's a completely undergrad population. So with this fellowship, I had an opportunity to learn what it was like to be faculty at this type of institution. And so teaching is a big part of what I do. I'd say probably about 75% of my time is spent with teaching. I also do some mentoring. So I was working with the senior design group, the biomechanical students. So I'm in the engineering department, and we're from a pretty broad department. And so I had some senior design mentoring, and I also do research. So I have a lab. These were my students from last summer, putting the lab together and learning how to use the technology. And so 25% of my job is also research, and I'm able to keep my relationship with my previous institution and keep some projects going there. So it's still a mix of teaching and research. And now I'm an assistant professor, so I was able to be converted over to tenure track. So I just finished my first year on the tenure track. And just to leave you with just a couple of things from my journey, definitely embrace your identities and find communities of support. So I know one of those communities is IWB for you all. I would also say invest in yourself and take advantage of opportunities. So as I said, teaching it was something that I just did on the side, and then I realized that it was really important to me. And it gave me a lot of meaning. Be strategic. So set yourself up where you can thrive and not survive. I mean, when I came to Hope, I tried to find, different departments that I could collaborate with. So I work with some faculty in kinesiology, and now I'm working with a professor in computer science. So you just want to make sure that wherever you go, that you're going to have options and you're going to be able to grow. And as a lot of my colleagues have said, make sure that you cultivate a network of mentors, advocates, and sponsors, people that are looking out for you, can give you good advice, but can also lead you to opportunities. And then lastly, I'll leave you with this quote from Audre Lorde. I remembered, some of these decisions I was making, I was a little worried about whether I was, making the right decision. And so she says, when I dare to be powerful, to use my strength in the service of my vision, then it becomes less and less important whether or not I am afraid. So that's just a little bit of my journey, and I'm happy to talk to you a little bit more about that in the breakout.
Thanks, Brooke. So that was very informative, and now we will have our Q&A session, and we're going to start for any that was produced in chat. But just before I ask any, before me or Anna ask any that was produced in chat, I have one question for you, Brooke, because you mentioned collaboration, and that was on my mind just because I know I just posted a Twitter thread where they was talking about collaboration in academia. How have you found that? While you may love collaboration, how do you find that give and take between others in your field for you?
So I think for me, it's just like building those relationships and starting small. So for example, with kinesiology, there's one professor who teaches biomechanics, and I just reached out to him like, hey, can I give a guest lecture? Can we just chat? Like, what do you do? And it kind of evolved to that. So now I do like one guest lecture, which is good because the biomechanics course that I teach in the engineering department, again, we're a very small school. So I only teach that class every other year, whereas he teaches biomechanics every year. So I at least get to talk about biomechanics once a year in front of students. So I think it's about starting small, and I always look at it as, again, thinking of things as this lens of service. What can I do to help you? So, I know that I can do a guest lecture. I can bring in my experiences as a biomechanist from the engineering side, right? One less lecture that you have to give. And so I try to think of things that way of like, how can I make this mutually beneficial for both of us, and just start small and start building that relationship. And then as you build that relationship, then you can move on to like bigger things.
Thank you. And I just want to say thank you all for agreeing to speak today. As a sports biomechanist, this talk has been eye-opening for me in so many ways, and I hope that everyone who's logged in on calls still it was just as eye-opening for them. I'm going to turn it over to Anna so she can ask any questions that have come from chat, because I'm currently having trouble with my chat.
No worries. It looks like no one has any questions in the chat. So I think to give people as much time as possible to meet our panelists, maybe we should move into the breakout rooms, and we can formally end the main session here.
Okay, so we'll go straight to the breakout rooms. The breakout rooms are divided into our presenters' names. You all have manual capability, so you can choose which breakout rooms you go into, and go forth from there. So let me start that.